Now we want to compute the determinant of the following matrix. So we are given that this matrix is a square matrix. That's why we can compute the determinant. So we are given that this matrix, let's call it A, it's an n by n matrix. So first, this matrix is almost an upper triangular matrix. It has ones on this the main diagonal and the small diagonals on the top. So it has ones everywhere here, but it has zeros on the bottom, except for this last row, it has two ones. Zeros here, except for this position here, the n minus 1 n, it has a 1, and of course in this n by n position it has 1 as well. So we are asked to compute the determinant. So we know in this case how to deal with such an issue. So we need to know one thing, okay? This last column has ones everywhere, so there is 1 everywhere. The same thing for this column, so let's call this one the nth column. The n minus 1 column has ones as well, so here we have ones everywhere. Okay, so in this case we have these two columns. Okay, let's call this one column n, column n minus 1 and column n. Okay, they are similar. Okay, and once they are similar, we can stop here, or we can do one more thing. If you don't see it, we can subtract one of the other. So we get, if we subtract this one from this one, we get zeros. So the last column becomes zeros everywhere. Okay, so when they become zeros, we can develop according to this last column, and we obtain the determinant is 0. So in this case, the determinant of A is 0. Okay, so this shows that when we have two columns that are the same, we always have a determinant that's 0. The key here was that to know that this element here is the same for this column, the n minus 1 column, the one before the last, and deduce that these two are the same, and we subtract each of one of the other, and we get the solution. Okay, and in any way, when we want to compute a determinant, once we have two columns that are the same, we stop. The determinant is 0. So because in that case, the volume is 0. So that's, you stop. But anyways, we will get to have more problems of this kind, because sometimes you have the Jacobian, when I compute the Jacobian, when we are dealing with like some huge integral, not that when we change the variable, we need the Jacobian, and sometimes you get into something like this. And once you do that, you want to compute the determinant, and if you see that 0, that means your integral is 0, and you stop without any further computation.